What's the sign of 0? What's the sign of 0? What's the sign of 0? Yeah, you know this from last unit and the unit before. What's the sign of pi over 2? Yeah, so like guys, last unit we got away from the unit circle and we just focused on the extremes. The sign of 0 is 0. The sign of pi over 2 is 1. Sign of pi is 0, etc., etc. But don't forget about the in-betweens. Let's not forget about the sign of pi over 3. What's the sign of pi over 3? There it is. What is it?
Root 3 over 2.
Root 3 over 2. Yeah, many of you have already forgotten. Many of you have already forgotten about the 60-degree tall 30, 60, 90 triangle with a hypotenuse of 1. We like to use triangles with hypotenuse 1 because SOHCAHTOA is easy to do when hypotenuse is 1, sine, opposite over hypotenuse, pi over 3, 60 degrees, root 3 over 2. Okay, what's the sign of pi over 6? What's the sign of pi over 6? Are we locked in, ladies?
I am.
Okay, stop being chatty. I'll break up the girl game. I would. I've broken up the cool kids and the bros before. I can break up the girl game. I'm warning you right now. Thanks, Jolly. It is a half. You guys remember the sign of pi over 4? What's the sign of pi over 4? What's the sign of pi over 4? Not 1. Great, thanks. Yeah, what's the sign of pi over 4? What's the sign of pi over 4? Great. Yeah, you had to think about that during the O, huh? All right, so there are angles between 0 and pi over 2. There were triangles. There are values that we didn't really focus on, but they were in the background. They were always there. And we are going to come back to these angles. We're going to come back to these values. We're going to come back to the unit circle in our triangles. So if you love SOHCAHTOA, it's back, okay? Now, if you didn't love SOHCAHTOA, bring it back. Draw your 60-degree tall 30, 60, 90 triangle. Your 30-degree short 30, 60, 90. Your isosceles 45, 45, 90 with its side length, please. Okay, the triangle's back. The in-betweens are back, guys. The angles are back. The angles are back. The pi over, the pi over 3. Are back. The pi over 6s are back. The pi over 4s are back. Hooray. Me too. But you know what? They were always there. We just didn't pay attention to it. Okay? Cool? we have been finding, though it's been a while where we cared about it, like the trig function of an angle. And we know that it's the trig function of an angle that equals a ratio. You have your angle, you have your ratio, that's what you've been finding. You socket the angle to get your ratio. Pi over 6, saw half, right? Now, what if I change it up on you, first of all? Change this from a 1/2 to a root 3 over 2, just for fun. What if I give you the trig function, I give you the ratio, but I ask you for the angle? This is a new situation. What is the angle? Not what is the x coordinate. It's trig function of an angle equal the ratio. We have one of those Jeopardy situations. You guys know what I mean by that? Jeopardy situation where it's like, here's the question, that's the answer. Here's the answer. What's the question? You know what I mean? Nah, we're not gonna use inverses. We're just gonna use our unit circle knowledge. All right, let's see if you can figure it out. Let's see. Write down your answers. What are your answers? Write your answers. What are your answers?
You want in degrees or?
Always in radians in this class block, and you guys are close. Yeah, you guys got the right idea. You're close. You're like halfway there. What we got? Oh, way to go. Look at you guys. Good job, guys. We'll work together. This is good. But you're like halfway, Chris. You're halfway. You're like halfway. Yeah, you're halfway there. Great job. Yeah, you're halfway there. No. How we doing over here, bro? You good? You good? What do we got? What angle is the sine of the angle equal to that ratio? What do you guys got over here? Ah, you're halfway there. Ah, you're halfway there. Oh, we like radians. Oh, you're not there. Oh, you're halfway there. Yes, please. Oh, you're halfway there. Oh, you're halfway there. Okay. Okay, well, you guys always think I'm not, you always think I don't know what I'm talking about. So funny. Oh, values. The values of x. You guys are most of the way there, which is good. Here's how I think about it. Listen. First, I pay attention to the trig function, which is sine, which deals with the opposite, which deals with the y's. And I pay attention to the ratio. I want my opposite to be root 3 over 2. Many of you / most of you were dead on when thinking about, I don't know how that happened, but you're dead on when thinking about needing a 60-degree 30, 60, 90 triangle whose opposite side is root 3 over 2. The sine of 60-degree root 3 over 2. You guys then said x equals pi over 3. Great, you're halfway there. Why? Because there's another angle than just that one between 0 and 2 pi, where the sine of the angle equals root 3 over 2. Now, here is my unit circle. I don't have to draw the unit circle, but we got your x-axis and your y-axis. Yes, you're correct. The sine of pi over 3 is root 3 over 2. You are correct. But there's another angle when the sine is equal to root 3 over 2. Which pi over 3? 3 pi over 3. 3 pi over 3 is all the way at pi, but that's not the first time people are going to do that. You got to remember, okay. Here's 0. Here's adding. Here's pi. Here's adding. Here is subtracting. Here is subtracting. Yo, stop. Is there another tall 30, 60, 90 triangle where the opposite is positive root 3 over 2? And yeah, there's one right there. This is 3 pi over 3. Subtract 1 pi over 3. You guys remember that? Okay. So, like I said, you were halfway there. I only saw the one. My bad. Your other people around you all put 1. All right, now, next question. When is the sine of x, we're still on this page, equal, let's change it. I'm changing my mind. What is the cosine of x equal to positive root 3 over 2? It's the same question, only I'm using cosine. All right, answer the question. Oh, I love it. Love it. Great. You got? Oh, good, Archer. Yeah, of course, Sheriff. Yes. You made the classic error. What do we got? Is that 5, 5, or 6? Yeah. Yeah, sorry, Shaw, you're wrong. Very good, very good. Now we're doing cosine x equals root 3 over 2. Okay, what we got? Oh, you made the classic error. Oh, you guys made it. Oh, I love it. Set you up to knock you down. Set you up to knock you down, Mac. Love you. Love it. Oh, man. Oh, I love doing this. Great. You guys are all like, I got this. Okay, we're good. You're thinking short 30, 60, 90 triangle. Let's see, we answered for this question. You answered pi over 3 and 2 pi over 3. You're thinking, okay, I need my short 30, 60, 90 triangle. I need my 30-degree angle so that the adjacent is root 3 over 2. And you're like, all right, that's cool, pi over 6. So then you're like, I got this, pi over 6. And then you put 5 pi over 6. That's wrong. 5 pi over 6 is not right. Cosine of 5 pi over 6 is negative root 3 over 2, guys. Come on. You're better than that. This is not correct. But there's another angle. What's the other angle? Oh, geez. Okay. So here's the things we got to worry about. That pi over 6. Here's the things we got to worry about. Ready? Solving trig equation where we can solve it without a calculator. One, you got to know your triangle. You got to know your triangles. You got to know soga toa. Two, you got to understand which trig functions are positive and negative where. Because you guys all screwed up, many of you screwed up on cosine x equals root 3 over 2. You told me pi over 6 and 5 pi over 6, but no, not that. Cosine is negative in the second quadrant. So I'm going to give you a little hand. I'm going to give you a helper so that we can easily find what's typically our two solutions, but not always. Everybody draw a little unit circle, just like a XY axis, please, in your middle of your paper. And if you guys think that it's like, oh, I'm not going to see Mr. Messner until next Monday, I have an entire weekend, like I will be up in your business during this lesson. Cool? Cool. So, ready? Yeah, it sounds like something. Ready? There. I'm not leaving. I'm not leaving until I get official confirmation because they've been working on this.
If we die, I pulled it. If we burn, those are leaving.
I'm not leaving.
Might be a time.
Yeah, told you. Thank you. All right. Now, ready? Yeah, don't leave. Tell me, in the second quadrant, what are your signs of your X's and Y's?
Your attention, please. We do need to evacuate at this time. Thank you.
Take our backpack and come back.
Don't take it back. So what we were talking about is you guys weren't paying attention to which trig functions are positive where. So I'm going to help you out. You seem to be pretty good on the triangles and the SOHCAHTOA, but here's what's going to help you out. Understanding first quadrant, X's are positive, Y's are positive. The second quadrant, X's are negative, Y's are positive. The third quadrant, both X's and Y's are negative. And in the fourth quadrant, X's are positive, Y's are negative. Tell me, which trig function is positive in the second quadrant? Tell your neighbors, which trig function is positive in the second quadrant? Are there any others besides the second quadrant? Besides the one? Are there two that are positive? Goes 1, 2, 3, 4. Okay, sine is positive. Cosine's negative. Tangent's negative. Cotangent's negative. Secant's negative. Cosecant is positive because it's a reciprocal sine. What about the fourth quadrant? What trig function is positive in the fourth quadrant? Tangent is not positive in the fourth quadrant. Cosine is positive in the fourth quadrant. We skipped the third. What trig function is positive in the first quadrant? All the trig functions are positive. Are there any trig functions that are positive in the third quadrant where X's and Y's are negative? Ah, you got it. This creates the mystical mnemonic, all students take calculus. But they don't. But we're going to say that. You could come up with your own little mnemonic device to remember ASTC. Who knows what mnemonic you come up with, I don't care. But ready. Cosine equals negative root 2 over 2. I immediately know which two quadrants I'm talking about. This quadrant, that quadrant. Now, either that's the first thing you think about or that's the last thing you think about. It doesn't matter. Use your triangles and your knowledge of SOHCAHTOA. Understand what trig functions are positive and what trig functions are negative where. Then you'll be able to get all of your solutions, whether they're 1 or 2 or none sometimes. So, what's the answer to cosine x equals root 2 over 2? Negative root 2 over 2, go. No, tell your neighbors. Or write it down on your paper if you haven't done it. Great. We know it's the 45, 45, 90 pi over 4s. It's the pi over 4s in the second and third quadrants. That is 3 pi over 4 and 5 pi over 4, knowing that 4 pi over 4 is the same as pi. Okay, change this to secant x equals, I don't want secant. Cosecant x equals negative 2. Ooh, cosecant, how do I figure it? Cosecant, well, guys, it's an equation. You do whatever you want as long as you do the same thing to both sides of the equation. Cosecant x equals negative 2. Let's take the reciprocal of both sides. Cosecant the reciprocal of sine. All of a sudden, you ever see a reciprocal function? This is how you deal with it. You flip both sides. Okay, answer this question. Sine x equals negative a half. Answer, go. Equals negative a half. Nope.
It would be, this one.
Yep.
That would be, that means the 1 on the right.
Guys, start with your triangle. Start with your triangle in SOHCAHTOA. Right. Nope. What do you got? What is the answer? Well, get the answer. Yeah. Good. All right, ready? Now, sometimes what I like to do is not even pay attention to the negative until the end. So I'm going to start with my triangle where the opposite is a half. Here is my triangle where the opposite is a half. That is my short 30, 60, 90 triangle. And then I know that that occurs at the pi over 6s. I want the pi over 6s when sine is negative. So I'm going to this pi over 6 and this pi over 6. I would expect you guys and recommend you guys draw just little unit circles everywhere. Now, which pi over 6 is this? Well, this is 6 pi over 6 plus a pi over 6. This is 7 pi over 6. Which pi over 6 is this? This is 12 pi over 6 minus the pi over 6. That's 11 pi over 6. Try my board. Yeah, fine. Go. One extra thing here. 2 plus tan x equals 1. Instincts sometimes need to take over. What are your mathematical instincts telling you to do? Good. Subtract 2 is nailing it. Let's isolate the trig function. Tangent x equals negative 1. It's easier than you think it is, you know? It's the aura. The aura. Figure it out. The aura. Cool. A, S, T, C. Tangent is positive here. Tangent is positive here. Tangent's negative there and there. Might be a little bit easier.
So the things are written are false. So negative is no.
Okay. Pi over 4s in the second and the fourth quadrants. Tangent's positive in the first and the third. It's negative in the second and the fourth. The pi over 4s are 3 pi over 4 and 7 pi over 4. Cool. One more. 5 cos x minus 2 equals negative 7. Go. You guys can join us over here. It's fine. You'll pick up where you left off. Oh, well, this one ends up being cos x equals negative 1. What? Yeah, we're out of triangle land. It's okay. We're back into the extremes land. We're back into most of the ones we worried about last unit. I'm sorry, Murph. You'll get it soon. Okay. When is the adjacent side negative 1? When we're going to the left all the way to our unit circle, that angle is pi. There's only one angle here. This is my favorite one. Sine x equals 0. Sine x equals 0. What is x? Yeah, so it really depends on what they ask you. Like here they say include 0, don't include 2 pi. The verticals are 0 when we are to the right and to the left. So that's 0, that's pi, that's 2 pi, that's 3 pi, that's all the pi's. But the way I wrote the interval is I want to include 0, but I don't want to include 2 pi. Look at up here. All right, cool. Great. Now, those are the basics, guys. When you do your homework, don't neglect to make sure you've mastered the basics. It's like sine of x equals negative root 3 over 2. Cos x equals a half. Sine x equals root 2 over 2. You should be able to think about the triangle. You should be able to locate the quadrants, and then boom, you got your pi over whatever. Now, this one, I would also say is a basic, but we got to do a little bit of work, and we got to make sure we remember something very important. I'd like your instincts to take over and try to get the answer here. Go. Good instincts. Now, first things first, I apologize for this. You've never seen this before. Squaring sine, and why is the square right here? Well, mathematicians are inherently lazy, and we prefer not to write parentheses if we didn't have to. If we want to square sine, and not square x, we want to square the sine of x. So we want the ratio of the opposite over the hypotenuse for any angle to always be a positive value. Boom. Shorthand is this. Okay? So In reality, I'm solving this equation, sine x squared equals 3/4. I want to get rid of that square. What do I do? Square root. You nailed it. Now, many of you are like, yep, I'm pretty good at this math thing. My instincts have not led me astray. You write root 3/2. You find your angles, and you're like, I got this. Root 3/2 sine. I got my tals. I got my tals in the first and the second quadrant. You need to get to be that efficient with things. But, you're all wrong, except for Ahmed here. Ahmed here's right. Why? What did I mess up on, Ahmed? What else? Everybody else mess up on? Yeah, don't we need a plus or minus when we square root to solve an equation? Nice. So I don't just want when sine is positive root 3/2. I want when sine is positive or negative root 3/2, which means I want every single pi over 3. Okay, write out all the pi over 3s. Write out all the pi over 3s. Is anybody making a mistake? Now, everybody's like, oh, sweet, pi over 3, 2 pi over 3, 3 pi. Okay, don't write 3 pi over 3. Don't forget, this is 3 pi over 3. That's pi. 4 pi over 3, 5 pi over 3. Okay, do this one. All right. We're not there yet, but yes, you have nailed it. Yes. What is this situation now? This is a little bit more advanced because we might not be sure what we're indeed looking for. I get cosine squared x equals 3/6, which is 1/2. I then square root both sides. Thank you, Ahmed. We remember we need a plus or minus, and I got the square root of 1/2. And I think to myself, what the heck is the square root of 1/2? It's 1 over the square root of 2? Yeah. What? We got it? What? Cool. It's root 2 over 2. And then I realized I need the pi over 4s. Not just 2 of them, I need all of them. So these questions are really like easier in some aspects. We don't have to care about the quadrants, but they are harder in other aspects because we have to make sure we can square root and simplify. So I got all of my pi over 4s. Don't put 2 because that's pi over 2. Put 3. Don't put 4 because that's pi. Put 5. Don't put 6. That's 3 pi over 2. Put 7. Let's move on. Okay, here goes. Sine theta equals negative root 3/2. Theta, x, whatever variable. Don't worry about it. It doesn't change the problem. So solve this. Negative root 3/2. Go. What we got? People come back at me. Yep. Okay, so sine is positive in the first and second quadrants. We need the tall 30, 60, 90 triangles in the third and fourth. So we want our pi over 3s. The pi over 3s here are 4 pi over 3 and 5 pi over 3. And we write this down, and Mr. Messer doesn't give you credit. Or full credit, at least. What is going on? Well, you didn't pay attention to the directions. and the difference between what I asked you here, which is find all of the x's in the interval from 0 to 2 pi. That was one prompt. So we actually just looked at one rotation of our circle. We did not go beyond that. But here, I ask you for all the solutions. So you got to think to yourself, all solutions, are there more angles where the sine of the angle equals negative root 3 over 2? And the answer is, of course there are. Just keep adding or subtracting multiples of 2 pi. Now, it's a good thing we got our friend the integer. Now, what is an integer? Tell your neighbors, what's an integer?
A positive or negative number.
That's a very important distinction. It could be a positive, it could be a negative whole number or 0, which means it includes all the minuses and the pluses of multiples of 2 pi. We can just add multiples of 2 pi to get our co-terminal angle. You don't want to subtract because n includes negatives. Got it? Cool. So this would be an expression for all my solutions. Okay, well now we get to my favorite one. We haven't encountered one like this, a tangent that is not equal to 1. Here we got tangent x equals root 3 over 3. Figure it out. Go. Figure it out. Isha, calling on you, bud. Call on you, Isha. What we got here, bud? Come on, let's get it right. I'm waiting for you. I like to call people trying to sleep in my class frequently. It's an easy thing to do. I know. You get it?
Oh, I know what it is.
Got figured out.
I genuinely know what
Got figured out. This is my favorite one. Got figured out. I like what you did there.
Oh my god, I know it. I have the answer.
You can figure this out. This is not new, really. It's just a different way of asking questions you already know how to do. What did you get? 1, 6, and 7, 6 pi? Yeah. Okay. I like what you did there. Now, guys, just telling you, for this unit, we're not solving these with a calculator, so we really are limited to only 3 types of triangles. Our 45, 45, 90. That can't be it because we know the tangent of pi over 4 is 1. We got a tall 30, 60, 90. Ooh, maybe that's it. Maybe it's the pi over 3. We got a short 30, 60, 90. Ooh, maybe that's it. Those are the pi over 6s. You got to figure it out. Now, hopefully, you have done the division of these two fractions so often by now that you could do it in your head. Hopefully. If root 3 over 2 is divided by 1/2, that's root 3 over 2 times 2 over 1. The 2's cancel. The tangent of this is root 3. Files. Meanwhile, over here, 1/2 divided by root 3 over 2 is 1/2 times 2 over root 3, which is 1 over root 3, which then simplifies to root 3 over 3. Ding, 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 ding. You have your winner. How'd you figure it out? You just figured it out. You started with your triangles. You used the Torah. Okay? Now, that's your pi over 6, but in the correct quadrant. Now, how many of you are like, oh, pi over 6 and 7 pi over 6 and multiples of 2 pi of that? Gosh, you're wasting a lot of time and effort writing all this answers. So much easier than this, guys. Who wrote this down? All of you? Of course you did. Of course course you did. Guys, how long does it take for tangent to start repeating itself? Pi. Oh, wait. This number is just a pi away from the previous angle, and then it's going to be a pi away from the... So, like, why'd you waste your time? You just needed one. You just needed one, and all of the other ones will be a pi away. Because the period of tangent is pi. Oh, great. Okay. Oh, guys, I love this one. Let's go to this one. What happens, let's think about last unit, when you put a 2 inside your parent function to the graph of y equals sine x? You horizontally dilate, the period gets adjusted, everything gets shifted in, you take your x's, you multiply them by a half. Now watch this. Let's pretend I don't have 2 theta. Let's just pretend I have the parent function sine x. And this is actually how you do this problem. Well, when is sine going to equal 1? Sine equals 1 at pi over 2 plus multiples of 2 pi x. Right? So that would be the answer to my parent function set equal to 1. But I don't have my parent function. I don't have the sine of x. I have the sine of 2 theta. Oh, okay. Well, what happens with that 2? You know it's a horizontal dilation. You know you multiply it by a half. But how about this? How do you solve this equation for theta? What do you do? Divide by 2. Right? So all of a sudden you are dilating, but the dilation just comes naturally through the solving. This is why on the inside we end up doing the opposite, because we're using an inverse. There's all of your solutions. So what do? Again, I just pretend like I have my parent function, maybe with a different variable. Start with your parent function. Tangent. Get your solutions, dilate them, or solve for x. So tangent equals root 3. Tangent equals root 3 at all the pi over 3's plus pi n's. I don't need 2 because tangent repeats every pi. But I'm not talking about my parent function. I'm talking about this manipulated function. I need to multiply everything by 1/4, all of my angles by 1/4 to dilate them. Okay, bringing us to inequalities. Don't worry, there's also real world problems that you're going to have to solve. This is a big lesson. Here's the key. You find your 2 angles, pi over 4, 3 pi over 4, where sine equals root 2 over 2. Pay attention. Think about the unit circle. Understand that there's any angle. What angle will sine be bigger than this? All of those angles between those 2. Which means I have an inequality, my angles between 3 pi over 4 and pi over 4. And since it's greater than, not greater than, equal to, I just need a symbols like that. I'm going to do the rest of these examples because I want to and I'm recording it. I hope everybody has a great weekend. It's good to see everybody. Yeah. It's super strong, isn't it? It's crazy. Is it the magnet or is it the thing?
It's a magnet.
Wow, right? Is that crazy?
It also got sexual outside. But I got it off that.
All right, so this guy, we got two different inequalities. But we're going to solve them the same way. Okay, let's just do them separately. Let's think about the sign being bigger than negative 1/2 over here. Let's do the cosine bigger than root 3 over 2 over here. Have a good one. We're going to find when sine equals negative 1/2. Okay, opposite being negative 1/2. Negative 1/2 is the shorter side in the 30, 60, 90 triangle. To get that, I want my pi over 6's. And I want my pi over 6's when sine is negative. Sine is positive in the first and second quadrant. So I got the signs there. Sure. Just sit over there because I'm going to be talking to myself. Now, if you think about our unit circle and the fact that we have an infinite amount of angles, when is sine bigger than negative 1/2? Well, it's like sine has a minimum value of negative 1 over here. It's got a maximum value of 1 over here. Sine is bigger than negative 1/2 up here. Cool. All right, so let's solve that one inequality. Now let's do the other inequality. Cosine bigger than root 3 over 2. Well, let's find when cosine equals root 3 over 2. Okay, we're still talking about this short 30, 60, 90 triangle that occurs at the pi over 6's. So I want the pi over 6 here, and where else is cosine positive? Cosine's positive in the fourth quadrant, so I want the pi over 6 here. Cool. Now, where is cosine bigger than root 3 over 2? Well, remember the cosine's minimum value is over here at pi. The cosine of pi is negative 1. The cosine's maximum value is over here at 0 and 2 pi. So where are we going to be bigger? Where's the adjacent side length larger? If we think about our unit circle, there. If I'm asking you for both inequalities at the same time, it's like you take this and superimpose it on top of that, which means I'm going to take this and I'm just going to draw it on top of the other one. Well, we share an angle there. We got that guy. And we got this shared space. It's really the same as this space. We're good. If we just answer this, we answer the combination of the two. Now, we're asked for the theta values between negative pi and pi. The reason why they ask us is it provides one continuous region. If we talk about going from 0 to 2 pi, we would have to go like from 0 to pi over 6. And then from 11 pi over 6 to 2 pi. And it's annoying to have to write two different intervals out. But when we change the question to negative pi to pi, we're starting at negative pi, we're going around to pi. Well, we got that interval seamlessly, but we don't write this as 11 pi over 6, we write that as an angle of negative pi over 6, and this as an angle of positive pi over 6. So we want our angles in between those two. There's primitive. Yeah, right there. Cool. Cool. Now, there will be some real world examples. Like we just modeled a bunch of stuff last unit. Well, I'm going to ask you questions about the stuff. Here, we got an interval 0 to 12. Well, it might be important to think about how your B can help you find the period. Oh, the period's 12. So we are talking about one rotation around my circle. Okay, so we're probably looking at two solutions here. Now I'm trying to figure out when is my height of my water above 5/2 feet. Now this is just like finding when it's above 1/2 of a foot after subtracting 2. Now just like we did before, think about your parent function. Sine of y. When is that equal to 1/2? Okay, well sine of y is equal to 1/2 at pi/6 and 5/6. And you will practice when you do your homework, getting more proficient at finding those angles, their locations. Do your homework. I might have to do the homework video too. Okay. Now, we can see we are going to be bigger with our parent function above here. So we're looking at the angles between there and there. But we're not talking about the angle pi/6 and the angle 5/6. We're talking about those angles being horizontally dilated. So this is where we can kind of just say, hey, if our inside of our function pi/6t equals pi/6 and 5/6, how do you solve for t? You use the inverse. This is the idea, not the inverse, the reciprocal. This is the idea of like, hey, take your angles, dilate them, multiply by 6/pi. You multiply everything by 6/pi, it gives you that the dilation changes this to answer for t of 1, because 1 times pi/6 is pi/6, and this turns this to 5. Plug in 1, you get pi/6. Plug in 5, you get 5/6. Your answers are your time values between 1 and 5. It's just dilations, translations like normal, only in equation form. Let's do one more of those. Height of the bouncing ball is modeled by this, where t is measured in seconds. The ball is bouncing for 2 minutes, which is 120 seconds. Now, my period is typically 2 pi, but b is pi, so I get 2. The period is 2. The period is 2 seconds. T is measured in seconds. Which means we're going through 60 periods of 2 seconds to bounce for 2 minutes. The idea of frequency. This is more like a last unit situation. Like if I take that function that starts at a max, it'll hit a min 1 time. This is more like last unit. I don't want to do this question. The homework questions are better. I'll show you what I mean. Like, this is how I would think about this question from last unit once my cursor comes back. Goodness gracious. There it is. There. All right, great. If I start with a midline of 5 and an amplitude of 5, and it's a cosine graph, I hit the ground once every 2 seconds. If I hit the ground once every 2 seconds, how many times am I going to hit the ground over 120 seconds? 60 times. That's probably the easier way to solve this compared to what we've been doing with solving in the unit circle. All right, just make sure you do your homework because there's lots of practice that will produce proficiency.